And welcome to our first traditional asynchronous lesson. So most of them will be going like this. Today is, you should be watching this on Monday, possibly on Tuesday, but hopefully on Monday, August 17th. So today we're talking about limits of graphs and tables, limits from graphs and tables. So yesterday we talked about, well, in class earlier, we talked about what a limit was and what it meant. And now we're going to talk about how to find them. We're going to get some more direct detail. So, you should have already downloaded the handout, Can You Shoot Free Throws Like Steve Nash? If you've printed it out, awesome. If not, make sure that as you're taking notes, you mark this as problem number 1 and maybe say information to make prediction. So what do you need? Steve Nash is the second highest lifetime free throw percent at 90.43. You decide to study his free throw in greater detail to improve your own shot, and unfortunately the video freezes. How accurately can you guess the height of the ball after 5 milliseconds? So, we have 2 and 7, that's what we know. And what information do we know? Well, we know we can see where it was at 2 seconds. And we can see where it was at 7 seconds. So we need to find the measurements. So we need to know the height of the ball. At 2 seconds. The last thing we see, and then the height of the ball at 7 seconds, because we know what time it was, but we don't know those heights. We'd have to measure those somehow. That's what we need. We already have these two. And what we'd be talking about with this situation is we'd actually just be doing a rate of change, an average rate of change to figure things out. So, your group will have several data points on the ball's path. Time given is in milliseconds, and height is given in feet. So I'm going to give you some information, and we're going to write stuff down. So we're just going to go ahead and fill out a table as quickly as we can. So we've got 0, 7, 2, 11.16, 3, 12.76, 3.5, 13.44, 4, 14.04, 4.5, 14.56, 4.9, 14.918, 4.99 is 14.992. So this is, the video is frozen. Like, we're getting really close. We've got this 4 seconds here, and then this is after the video because it froze at 5 seconds. We don't know where it is. So then coming right after 5 seconds, we've got 5.01 is 15.008, 1 is 15.078, and 5.5 is 15.36, next number is 6, 15.64, 7, 15.96, 8, 15.96, 10 is 15, 14 is 9.24. So as you can see in the first one, the ball is on its way up, and then the second one, right about here between 7 and 8, the ball starts coming down. Somewhere here it goes from up to down, because after here it's going down fairly quickly, but again, these are spread apart. So it's going up, 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 and then it starts coming down, which is what a ball will do, right? We launch it, and we figure out what's happening. So the question is, let's go back to the question. Receive several data points given, record, and what are we trying to find out? We're trying to figure out how high the ball was at 5 seconds. So if you notice in this red table, as we get closer to 5, we kind of slow down. Like, we're going pretty fast here. 0, 2, 3, 3. Oh, we start to slow down in our increments. And so we can see that right here at almost 5, where's the height of the ball? And when we talk about this, the notation we're going to use is the limit as t, time, approaches 5 from the left. So that's what this minus sign means. Of h of t, the height of the ball, and what's it equal to? So we'll come back to that. And then this one, notice that we're going away from the ball, away from 5 seconds. So we're still doing a limit as t approaches 5, and this time from the right, because we're kind of approaching 5 this direction, whereas this one we're approaching 5 that direction. So we're approaching from the left, and now we're approaching from the right. Of h of t, and what is that? Well, it looks like, what are we getting close to? Looks like we're getting close to 15 in both problems. And so do our answers agree? Yes. What does this tell you? This tells me that the limit as t approaches 5 of h of t, since my left and right hand limits agree, since both numbers are going towards the same value, is 15. So yes, and so the ball must have been, let's use a sentence, at 15 feet after 5 milliseconds. Okay, and so that's the idea. We use that kind of path, we look at this, and we're using this table to tell us where it's getting close to. So what if instead we had a graph? So instead of all of that, we had a picture. So we knew this equation. Using a calculator, graph the function. So whenever I use a calculator, I'm going to want to use Desmos. So I'm going to go ahead and jump over to Desmos here. And go ahead and shrink this thing up a little bit so it fits in here. Graphing calculator. Okay, and then I'm going to type the equation I was told, which is h of t equals negative 0.16 t squared plus 2.4 t plus 7. So here's my picture. I'm going to kind of shrink it up a little. Okay. You'll notice the initial, whoops, excuse me. The initial height is right here. Let's right here at 7. The peak happens at 7.5 at 16, and then because the stuff over here doesn't matter, and then it comes down at 17.5. So, comma 0. So those are the points I'm going to plot on my graph. So I'm going to go to my graph paper now that I have that picture, and you'll be able to keep it in the screen and whatever. I'm going to start at 7. I know that at looking again, actually I'm going to go ahead and shrink this up even more. Never mind, that's not what I want to shrink. It was 7.5 comma 16. 7.5 comma 16 on the ground at 17.5, which I don't think is on my picture. Yeah, it goes to 12, so it's on its way back down though. So I'm going to just kind of sketch in a picture. It's quick, you know, best I can do. It doesn't have to be perfect. You know, just a quick little sketch of what's happening. Using calculate graph, label your axes. So our axis, this is height. My finger is in the way. It always is when I try to write up. In feet. This is time. In milliseconds, ms. Okay. It's very important that we have our units. You can do, this in doesn't need to be there if I just put the parentheses, and that's way easier, so I'm going to do that on both of them. my sideways writing leaves a little to be desired, so I apologize for that. Not important. Okay. Trace the graph as it increases towards 5. So 5 is what we care about. That's the value we care about, is here. So as I trace the graph to 5 in both directions, where am I going? And this will be easier to see on the computer, but it looks like I'm approaching both directions, from whichever side I approach it. It looks like I'm coming to the same value of 15. Trace the graph as it decreases, trace the graph as it decreases. We are approaching 15. Without the graph, how else could we have found the height of the ball as it closer and closer to 5, knowing the equation? So one of the really cool things, and this is probably cooler on your calculator, but I can make a table. And so with Desmos, I make a table really simply. If I click on this and I go into settings, one of the things it says is convert to table. And so then it makes a table underneath. And I want to get closer and closer to 5, so I'm going to go ahead and type in 4, 4.1, 4.5, 4.6, 4.9, 4.99. When your TI will do a better job with this. 5.001, 5.1, and so on. This is a table way. Or of course we could just plug in 5, right? We could just go, hey, what is h of 5? Oh look, it's 15. But sometimes we have some issues with that. So just going to keep that in mind, that that's the table way when you're making your own table, and this is the fast way. Okay? All right. So that's that. Now the next thing we have, if you turn your page over, if you're on the next page, is this table. So we're going to have blank tables like this all the time. They are the most important part of the lesson. So I don't leave these to chance. Here is the answers. I will get this out of your way. And I want you to write this down. Then we'll come back in the next video, because we have to do 2. We will go over the check for understanding. Okay, so try the check for understandings on your own, and we'll talk about them more in the next video. But this you need to write down every single thing. If you can use color to redo it, that's awesome. So just kind of keep this in mind. This is what the important part of this video was. Okay, I'll see you in a minute.